Everyone, welcome to my channel. So in this video I'm going to cover the solution to this question and at the same time do some lab coding work. I'm also going to follow the general stuff, so you should follow in the coding interview when we solve this problem. So let's get started. Before we start the real content for today, I would really appreciate that if you can help subscribe to this channel. So let's first resolve this problem. We are playing the guessing game, so the game will work as follows. I pick a number between 1 and n and you guess a number. If you guess the right number, you win the game. If you guess the wrong number, then I would tell you whether the number I picked is higher or lower, and you will continue the guess. Every time you guess the wrong number x, you will pay x dollars. If you run out of the money, then you lose the game. So given a particular n, return the minimum amount of the money you need to guarantee a win regardless of what number I pick. So let's take a look at the example. It says that n is equal to 10. We need the minimum amount of the dollars in the pocket is 16. So let's see the constraints. The constraint says that n is anywhere between 1 to 200. So I think we pretty much understand what the problem is asking us to do. Not too much to think about the edge case. So actually it seems to be like a binary search, but it's not like a traditional binary search question. That is because it is not like asking us to search something within the array, but instead it's asking us to see what is the minimum of cost to search this kind of stuff. So let's see how to solve this problem. So I think one brute force solution, which is pretty obvious, is what we could do is we can do like an exhaustive search. When I say exhaustive search, it's something like enumerate all the pivots. So for example, when we get a pivot, when we choose the pivot 7, we need to search in the left part or the right part depending on which number we are going to choose. So suppose the function we define, like a DFS function we define, is going to return the minimum amount of the money we need to have in pocket to guarantee a win when we search within a range from I to j. Then it's something like when we search the left part, we have the minimum amount of the money we need. When we choose pivot at 7, and we have similarly we have the minimum amount of money we need to guarantee a win when we choose when we search the number within the right part. So essentially, when we choose pivot at 7, it's pretty much like 7 plus whichever is more costly on the left part or the right part. And then we enumerate all of the pivots and choose the minimum amount among all of the pivot we choose. So essentially, this kind of the question is choosing the minimum among all of the maximum. So having said that, the brute force solution is not actually good regarding the runtime, wasting a lot of the computing resource, recomputing the solution to a same problem. So instead, what we could do is we could use dynamic programming to actually memorize the solution to the subproblem and then reuse it to recompose to compose as a solution of the original problem. So for the DP, if you go bottom up, but it's okay to go top down as well. But if you choose to go bottom up, we need to define like the DP array here. So here the array is actually a matrix. So let me define like the DPIJ is the minimum amount of money needed to guarantee a win when searching within I and j. So that's how we define the DPIJ. And how to compute the DPIJ. So the DP formula DPIJ is actually suppose I is when I is equal to j, then it is like a 0 because we know that we are searching within I and I. Then it's essentially we know what the number is. So let's see. So DPIJ is actually like I said, it is a minimum among all of the maximum. Suppose I just choose a pivot, and the pivot, it should be something like we search on the left part, which is I pivot -1, and then okay, so this should be like max. So the maximum among whether we search on the right part or whether we search on the left part. So this would be something like pivot +1 to j. So that's essentially the formula, DP formula we are going to use to compute this problem. So having said that, the runtime is going to be n squared. That's because we have 2 layers of the for loop outside, and then within and the inner for loop is actually we will need to enumerate all of the pivots. So that makes the runtime to be n cubed, and the space wise is going to be n squared. That's because this is like a 2D array we are going to have. So having said that, let's actually do some coding work on this approach. So first of all, we need to define the DP array. So let's say we have like the DP array as n+1 and n+1. And then finally what we do is we just return DP1 to n. And that's pretty much it. And then it comes to the rest of the computation. As I said, it's like 2 layers of for loop. So since this one it's actually enumerating all of the middle points, so we cannot actually do a like a first layer is I, second layer is j. We cannot do that, otherwise we are going to get the wrong answer. So instead we need to like enumerate all of the lengths. So when I say the length, it's actually the distance between I and j. So I would say the length is 2, starting from 2. Like we try to include 2 numbers, and then length is anywhere from 2 to n plus the length. And then we are going to have like let's call it, instead of I, let's call it a start, which makes it more meaningful. So start is actually anywhere from 1, and start should be smaller or equal to, this is n minus the length. So if it is n minus the length plus 1, okay, and the plus the start, and then the n is, so n is actually the j here, so I just give it a more meaningful name. So start plus length minus 1. So this is the length. So let's say we have, yeah, so it should work. So this is the start and this is the length, and the rest of the job is for us to enumerate all the pivots. So pivot is equal to well, this should be starting from start. Pivot is smaller or equal to n plus the pivot. And DP, we need to have like something at the first place because we are trying to get the minimum of that. So let's say we have the current min defined as integer dot max value. So current min is among all of the minimum current min. This is pivot plus, this is second choice is a pivot plus, I said it's like the maximum among the right part or the left part. DP, so the left part is I, which is start to pivot minus 1. The right part is pivot plus 1 to the end. And then finally we are just going to have like dpij or dp start to end set as current min. So that's pretty much it. Let's try to do some debugging work on this platform. Okay, so it says that it is out of the range. Okay, so that, I think that's because we have the pivot plus 1 and the pivot could be like equal to the end. So that's essentially why it is wrong. So instead what we could do is we could define this, we can add another dimension on top of this. I think this can solve this problem. Alright, so let's do some more testing. Alright, so seems like it takes some time. Alright, so accept it. Let's do a submission for it. Alright, so it seems like we are done with this problem, and we are good. We are pretty much in good shape. If you have any question regarding the solution or regarding the code, feel free to leave some comments below. If you like this video, please help subscribe to the channel. I'll see you next time. Thanks for watching.